to play with 14 degrees. In other words, find all the solutions which have the same cosine as 14 degrees, and I'm working from minus 360 to 360. Again, just carrying on the video. So let's just draw one of these little grids again. Very easy because, again, a nice acute angle. Let's make it look quite acute. There we go. So that's 14 degrees there. We've got the equivalents here. So 14 degrees right there. That's the first solution. And that's positive there and there for cosine again. So if it's 14 degrees is acceptable, then minus 14 is also acceptable for the second solution. Working around this way, we have this solution here, which is going to be 360 take away 14, which is 300, I don't know, calculator, 360 take away 14 gives us 346 degrees. That's the positive one, 346 degrees. Or we can work the other way, starting from here, say, all the way around in the clockwise direction, but negative. That's going to be 360 minus the 14 is going to be minus 346. So these are the four solutions again. Does it make sense? Well, 14 degrees is about here, say. So you're going to have a solution there and there, and all the way across here, almost to 360, but not quite. And there's the four solutions, roughly speaking, in terms of their position on the graph. Right, now what about this troublesome 225? Not looking forward to that one at all. 225, here we go, thinking on one's feet. Put a great big one down here so we can work. 225, what it's going to be based on, I don't know, but let's have a go. 225 clearly takes us into the third quadrant. So we've got positive, negative, negative and positive. 225. If I go 225 take away 180, I've gone 45 degrees over the 180 mark. So remember this, 0, 90, 180, 270 and back to 360 again. So what have we got? We've got the 0 there. So we're looking at 45 degrees like that beyond the 180. So the first solution is going to be obviously 225 degrees. In order to be negative, to match the cosine of 225, then we need to work out this angle right here. Well, dead easy. If we're based upon 45s, and this angle is therefore 45 as well, because these are vertical opposite as are these two, then we're looking at 180 minus the 45. So the other solution is going to be a positive 135 degrees. Is that okay? Now we can match both these angles working in the clockwise direction and getting their negative equivalents. So if I start from, say, I don't know, here and go anti-clockwise in the positive direction, that's going to be 180 take away the 45, hence minus 135 degrees. In the same way, starting from here and trying to avoid all my little arrows, going all the way around here and bam, landing there. I'm going 180 plus 45 is going to be negative 225. So these are my four solutions: 135 minus 135, 225 minus 225. Does it make sense? Well, 225 is going to be about here somewhere. Again, we're just guessing here. So we've got a solution there. Just cut straight across, solution there and there. This must be the minus 13, whatever it was. Yeah, minus 135. And here we've got a positive 135 and a positive, what was it? Yeah, positive 225. So again, it makes sense from the shape and positioning of the graph. All right. So if this was the line y equals, actually doesn't really matter. I know the position of 225 is going to minus 2 of 225 is going to be here. Therefore, I'm going to have a solution there, there, and because the symmetry of the graph, solution there and there as well. So all right. So just rub this out. Again, make space for the next one or two. Rub that out. Now we're based on 198s. Oh, wonderful. We're starting a fresh page, I think. Right, 198. Let's give it its own page. So 198 take away 180. We're based upon 18 degrees, so it's quite a thin slice, isn't it? Let's make it look all thin and realistic. Right, 198 is going to be this one. There's the first solution, 198 degrees. Look at it. It's 90, 180 plus the 18, 198. And again, looking for negative solutions. So the next solution is going to be right here. So just fit it in there. and we're looking at therefore 180 minus the 18 degrees. So let's write it in fully. So 180 minus the 18 gives me a solution of 162 degrees. 162 degrees. Again, working in the clockwise direction, we have a solution from here all the way around to there, which is going to be 180 plus the 18, which is going to be my negative 198. Remember, we're going in the clockwise direction, so it's minus 198. And the last solution would be this one that stops right there to match the 198 line. So what we did was to go from here, from 0 degrees, and went minus 90 just to this point here, and that's minus 180. So therefore we're short of 18 degrees. So you're looking again minus 162. So let's just do that in minus there. So it's going to be 180 minus the 18, 162, but it's minus 162 degrees. 4 solutions. Alright? Does it make sense from the picture? Right, so we're looking at this one here, 198. 198 is about here, and the solution is going to be sort of there. And using the symmetry of the curve there as well, reading over like so, looking at solution there and there. Again, this is really crude, but it does make sense. Right? In an exam, make use of the curve that you're given, and also using the grid on the other page, which is a really good visual picture of what's going on. Alright, so you're based on, oh, that's the previous question. So we're based on 18 degrees, so do a thin slice like that. We go 180 plus the 18, so that's our initial first answer. In fact, that first solution is given to us anyway, and therefore we're playing with 18 degrees in all directions. So 180 take away the 18 gives you that little piece there, etc. Just work through systematically. We'll add another page, go back a couple of pages and grab the next question. Now we're based upon, what's it say, 286. Rubbing out again, so we make space for the 286 solutions. 286. Right, big grid, quick calculation. Let me go 360, take away 286, and I've got 74 degrees, so I'm playing with 74 degrees this time. Let's make it look bigger now. So what have we got then? We've got 74 degrees in the positive direction. These are all positive answers, negative and negative, and that's going to be minus 74. So 286 degrees. So here we go, 90, 180, 270, and now we stop, because in this position we're going to go 360, here we go, 0 or 360, going all the way around, take away this 74 right here. So you've got minus 74 as a possible solution, and here we're going to have 360 take away the 74, which is 286. Of course that was the original, wasn't it? Right, so how do we access that? We can go positive 74 or positive 286 or negative 274, and of course the other one's going to be negative 286. So start here, say minus 90, minus 180, minus 270, and stop. There we have the minus 286 in this. Alright, so 4 solutions, minus 286, 74, minus 74, and positive 286, and that was the original question. And let's go onto the final grid now, and we'll prepare the last one, and we'll get back to you in a minute. Set it up. Again, just recall what I'm doing. 0 degrees, 90, all in the positive direction, 180, coming round again, 270, and back to 360. And of course we can go anti-clockwise as well. Sorry, clockwise in the negative direction, anti-clockwise being the positive direction. Now, let's find the original question again. Right, I've now got to work with 352 degrees. That looks really awkward. Well, or is it? Well, 352 degrees is essentially, where's she gone? Right, is essentially all the way around here minus 8 degrees. So really, even though the diagram's terrible, we're based on 8 degrees, aren't we? Okay, because all the way around to here is the original question, 352 degrees. Again, positive solution, positive solution. So there we go, one solution straight away is 8 degrees, done. And if we work around this way in the positive but anti-clockwise direction, we've got -8 degrees. So there's 1, 2, 3, 4 solutions, 1, 2, 3 solutions, and the last one's going to go, or let's make some space then, all the way around to here and hit the 8 degree line. So we've essentially gone all the way around to 360 minus that little bit of 8. So it's -3, 5, 2 degrees. And these are the solutions.